So you've probably met with binary numbers already. In this video I'm going to be explaining basically these 5 points. What are they, where to use them, how do they work, what is most significant bit and least significant bit, and binary to decimal and decimal to binary conversion, which is going to help us understand the topic the best, in my opinion. Okay, so let's get to it. Okay, so binary is just like any other number system, just with one small exception. Since it's in the name, the bi in the name means 2, which means this number system only has two options for representing its data, which is basically 1 and 0. Yeah. Okay, we are going to look at what the 1 and 0 represents later. Now we are going to focus on where to use them. So basically they can be used in, well, they are mostly used in computers, where, for example, when you have a logical circuit, you have a voltage being in it, and if you have 5 volts on a wire, that means you have a logical 1 in the circuit, and when you have 0 volts, it's logical 0. Yeah, this is the ideal situation. It's actually never like this, and that can cause issues we are going to look at in some later videos. For now we can just remember this, and yeah, they can be used basically elsewhere as representing data, since it's probably the simplest way to represent data, but we mostly use them in computer science and digital electronics, since yeah, that has the widest possibility of usage. Okay, so basically they work like any other normal number system, which is, yeah, we write a string, for example, number 5, and yeah, this represents a number 5. I'm going to tell you how to convert this later. Just for now you'll have to believe me that it's 5. Yeah, so we have a number 5. For example, we can write number 10. I hope, no, that's 12. Yeah, so for example 12, and so on. We can count in those numbers, we can add them, we can multiply them, we can divide them, basically like normal numbers, but this makes it easier for computers to process them and use them furthermore. Okay, so as you can see here, there are only ones and zeros. So basically this bit, that is the leftmost bit, it's the most significant bit, and the bit that is the rightmost, it's the least significant bit. In the most applications, the least significant bit is going to have a value of 1, and the most significant bit is going to have a value based on how big the string is. So if you have, for example, 4-bit number like this, the most significant bit has a value of 8, and the least significant bit has a value of 1. So yeah, how do we convert from binary to decimal? So okay, so basically the conversion works like this. It's when you have a decimal number, you can write it like, for example, 335, I'm sorry. Yeah, which is basically 3 times 10 to the power of third, since this is the second, I'm sorry again, since this is the hundredths. So then this number is like 3 to the 10 to the power of 1, and the 5 is 3 times 10 to the power of 0, which is basically 5 times 1, which is basically a5. Yeah, we can write it as addition of these 3 numbers. Same likewise with binary. When we have when we have number 5 over here, we take 1 1 times 2, because this is a binary, this is not decimal like here, to the power of 0, because this bit is always 0, the least significant. Then we take 0 times 2 to the power of 1, 1 times 2 to the power of 2, excuse me, and 1 and 0 times 2 to the power of 3. Yeah, which this basically is that one. This is basically 0, since it's 0 times something and it's always 0. This is 4. This is 0 again. Yeah, this would be 8 if there was a 1, but there isn't. So when we add them, we get 5. Yeah, so basically this is like 1, 0, 4, 0. Yeah, which is 5. Okay, so the conversion backwards is a little bit more complicated in my opinion, but it really isn't. It's working on the same principle. So, but the other way, yeah. So when we take 5, how would we how would we do this? Okay, so first of all, we would just go 335 divided by 10 is, yeah, no, actually, what am I doing here? It doesn't work. Yeah, let's go into this. Okay, so 5 divided by 2 would be basically 2.5. Since we have the remainder, we can just write 2, and the remainder is going to be written as 1, as this one. So then we have 2 divided by 2, which is yeah, wait, in a better way. So 2 divided by 2, which is 1, which we are going to write off as 1 as 0, because there is no remainder. And then we do 1 divided by 2, which is yeah, which is basically 1, but there is a remainder of 1 as well. So yeah, and then we can just write the 0, since we can write zeros anywhere we want, since it doesn't really matter. And yeah, then we just write the number like this, like this one goes here, 1, 0. Yeah, wait, actually no, we are going to write it like this. Yeah, so yeah, basically like this. When we get this, we are going to write it like this, and this should give us the binary result, which is going to be our binary number. So yeah, this should explain everything I wanted to talk about regarding this topic, and yeah, I hope it helped. You should now know what binary numbers are and how to convert from binary to decimal, and vice versa, which can be handy in some situations. So yeah, that's kind of it. So yeah.